Yes, we are in Form 2, Topic 2, Measurement 2. I want to welcome you for this lesson. As you watch the lesson, take your notes, observe what happens, and be very keen. It's as well like being in class, and we pray that the corona pandemic to end soon so that we resume our lessons normally. I'm Teacher Nyangoya from Kisii School. If you have comments, you can email me nyamirai2@gmail.com or call me. My number is already given there on the screen. Welcome. Today we are on measurement 2, and our specific objectives are, by the end of this lesson, you as the learner should be able to measure length using vernier caliper and micrometer screw gauge. Express quantities in correct number of decimal places and correct number of significant figures. Express measurement in standard form. Estimate the diameter of a molecule, oil molecule, sample. Solve numerical problems in measurement. But for only today, this lesson will only cover the vernier caliper. That is the vernier caliper. Our vernier caliper has got the following. It has got a vernier scale. It has got a main scale. And it has got jaws where you fix and measure. So the main parts and functions of the vernier calipers are as below. Inside jaws, they measure internal diameters. Look at this one. Outside jaws measure external diameters. We have a screw. We have the vernier scale. We have the main scale. Actually, this is how it looks. The vernier scale slides over. See? So you place an object inside here, then you fix it for you to want to measure. Another example, look at this. You have an object, for example, a beaker. You place it here to measure the internal diameter using the outside jaws. Then you are able to put like this. Then it touches both ends for you to measure. Or you have cylinder. You want to measure the external diameter. Slide over like this. Then you measure. So we resume on what we are talking about. So we have outside jaws to measure length of the rod, diameter of a sphere, external diameter of a hollow cylinder. Inside jaws to measure the internal diameter of a hollow cylinder. Strip to measure the depth. Hope you are getting the strip is here. Main scale to measure the length correct up to 1 millimeter. Vernier scale helps to measure the length up to 0.1 millimeter. We are saying this scale down here. The main scale is this one. The strip is here. So what are we saying? When you do the strip, you see something getting out. Let's see which one shows the strip. You see the strip, the strip getting the other side, this one. When you come this way, the strip bends. As this one slides over here 0, 0, the strip also ends here. So it can measure the depth, it also gets out. So we are saying this is the strip. So we have said Strip is to measure the depth of the beaker or a bottle. Okay, the vernier caliper has two main scales. The main scale is contained on the steel frame and is graduated in centimeters, but also has millimeter divisions. The vernier scale is contained on the sliding jaw and has 10 equal divisions. See that? This has 10 divisions. The main scale is here, and which is on the main frame. The vernier scale has up to 10 divisions. So as you slide, there is this one here, there is this scale here. So get back to the length of the vernier scale is 0.9 millimeter, implying that each division measures 0.09 or millimeter over centimeter, sorry. The difference between the main scale division and the vernier scale division is called the least count. This is the accuracy of the vernier caliper. So, which is actually not 0.9. This is 0.1 vernier scale. You rectify this. This is not 0.9. I want to do it immediately. You rectify so that we are able to do the correct thing. This is 0.1. Main scale measures 0.1. 0.1. Then the vernier scale 0.09. Saying these are 10 divisions. These are 10 divisions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each division measures 0.1. This one here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 divisions. They measure 9 millimeter. So it's 0.9, which is actually 0.09 centimeter. This one here, that's for a single division here. This one here for a single division measures 0.1 centimeter. That's why we are saying the difference between the two accuracy of the two instruments gives us the main accuracy of the whole instrument. That is what we are saying, that the accuracy of the vernier caliper is given as 0.1 minus 0.09, giving us 0.1. This one is coming from the main scale, this one is coming from the vernier scale, giving us 0.01 a centimeter. Vernier calipers has inside jaws used to measure the internal diameters and outside jaws used to measure the external diameters. Using vernier caliper, how do we use it? Place an object whose diameter or length is to be measured between the outside jaws. To do that practically, set. So, for example, we take a block, place it inside here. What do? Next procedure is to close the jaws till they just grip the object. Close till they grip the object. Very good. Then, the next thing is record the reading of the main scale opposite and to the left of the zero mark of the vernier scale, is what we are saying. This scale has been extrapolated and it is here. So you record what is the main scale reading. How do you record? You are fixed here. This is 2. We said every point here is 2.0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, such like. So, and this reading, for you to read what is in the main scale, you read up to where the vernier scale starts. So this is 2.12. You can't say 2.3 because the vernier scale has started. So you record 2.2. You record 2.2. And what is the next thing? Read the vernier scale mark that coincides exactly with a main scale mark and multiply it with the least count. This is called the vernier scale reading. So you go to the least count, the vernier scale, you look at the divisions until you find a division which coincides with this one and makes a straight line. To me, it will be this one here. So if you count 1, 2, 3, 4, 5, 6, 7. So you have 7. 7 you multiply by the least count, 0.01. It will be 0.07. What is the next thing? The sum of the vernier scale reading and the main scale reading gives the diameter or the length of the object. So you have got vernier scale reading equal to vernier scale reading plus main scale reading. Our vernier scale reading was 0.07. Our main scale reading was 2.2. So you add 0.07, it will be 2.27. Can I have another example? You're saying? Yeah. For example, a reading is here. So what is it? How do you read? Read what is in the main scale reading up to where the vernier scale starts. You go, you find it here. You cannot read this because the vernier scale has already started. So you read what is here. This is what? 1.0. 1.0. Then you look at the division until which one coincides. This one coincides, the fifth division. You multiply it by the least count of 0.01, which gives you 0.05. So it will be 1.0 plus 0.05, which is going to give you 1.05. I want to repeat another reading. For example, you have a reading here. You have a reading there. So what do you read? You read the main scale reading. 1.0, 1.1, 1.2. You record 1.2. Then you go to the vernier scale. Which division coincides? The fourth division. Multiply by 0.01, giving you 0.04. So 1.2 plus 0.04 gives you 1.24. Correct? So we are saying, like example is here. You have 4, you have 5. So which division? 4.5, 4.6. You record 4.6. Then which division coincides? 1, 2, 3, the third division. The vernier scale reading will be 3 times 0.01 gives you 0.03. So what is the reading now? It will be 4.6 plus 0.03 giving you 4.63. I want to give you a summary on how you are supposed to read this thing. If you look at it keenly, the vernier scale gives us the second decimal place. So you will only read the main scale. Like for example, here I can read the main scale 4.6. What is the division coinciding? The third division. So I'll write 4.63. I just place this one as the second decimal place. After I've obtained one decimal place from here, 4.63. We'll take another example here. Take another example here. This is 0.12. Which division coincides? 0.2. So 0.2, which division coincides? The sixth division. So the answer will be 0.26. What is in the vernier caliper? What is in the vernier scale is your second decimal place. If I place it here, You read up to where the vernier scale starts, 0.5. Which division coincides? 6. So the answer will be 0.56. Come here. This is 0.9. Which division coincides? 6. So the answer will be 0.96. Come here. 1.0, because this is already 1.0. 7. 1.07. This one here. Which division here? Main scale reading 1.3. Then you add your second decimal place 4. 1.34. So our vernier scale leads up to 2 decimal places. Let me give you one. Can you read for me that on your own? Correct. 1.14. Can you read this one? Correct. 1, 2, 3, 4. So 1.42. You're done. So let's take examples on how you do these kind of measurements. You set, for example, it is set here. Then you bring the object, place it here, you slide over until it touches the edges like that. Then you read. You read, for example, this one. This is 2. Chances are this one was 0.9, even like that. So this is 5, 6, 7. You read 1.7. Which division coincides? You go slowly until you find a division which coincides this one. So it's going to be 1.71. 1.71. Take another one. You have a block. Slide over. Yes. Then this is 4.0. 1 has not started, is after. So 4.0. Which division coincides? Follow it slowly. 9. So 4.09. Take another one. Take a beaker. So a beaker now, it's internal diameter. You just put like this so that it touches both edges. Just put like this. So what is it? 4.1. 4.1 is here. Then which division coincides? 0, 1, 2. Second division. So it's going to be 4.12. See that? What have we not measured? We go to the cylinder. Cylinder, you want to measure the external diameter. Correct? Slide over. Pop. Then measure now. 2.2 main scale reading. Which division is coinciding? Angalia vizuri. This division is coinciding. So this is 5, 6, 7. So 2.27. So write down the vernier scale reading in the diagrams. Like for example, this one. You also have this one. This is 0, 1. Then you have that one. Then you also have this one. So for today, you have known on how to use the vernier scale. Our next lesson will be the zero error of the vernier scale. Zero error of the vernier scale. As you still continue with my assignment, just refer to the notes and the same video clip to assist you know how to use the vernier scale. So we are remaining with error. After the error, we will move to the micrometer screw gauge. Those very few remarks. Have a good day.